Good afternoon, everyone. We are the members of Group H, and our presentation will be based on arithmetic progression. Our group members are Ms. Kumari Hanif, Ms. Renee Holder, Ms. Rachel Hunter, Ms. Shaniko Class, Ms. Shemlin Leandro, Ms. Lisa Ramprasad, Ms. Taj Roach, Ms. Dankumari Sukraj, Mr. Bharat Chintuman, and myself, Miss Kalitia Bristol Anderson. Now, in mathematics, we would frequently encounter numerical sequences that follow a specific pattern. And a common type of pattern that occurs when the numbers consistently increase or decrease by a fixed amount or a fixed number. This pattern is known as an arithmetic progression or an arithmetic sequence. It helps in understanding and predicting the subsequent terms in a sequence with ease. Now, the definition of an arithmetic progression is basically a sequence of numbers where the difference between any two consecutive terms is called constant, and this constant difference is called a common difference. Now, the common difference isn't necessarily subtracting only, it can also be addition. Now, whenever we're given a situation where we have to find the nth term, there's a formula that we should follow, and it's stated here, which is equal to a plus open brackets n minus 1 close brackets d. Now, the a would be the first term of the sequence, and the d stands for the common difference, which is the number that we are increasing or decreasing our terms by. Let's look at an example. Now it says here to write down the first 5 terms of an arithmetic progression with the first term being 8, or the 8th term being 8, and the common difference being 7. I will now share my whiteboard to work it out and let you see how it is done. So remember, it says that the first term is 8, right? Good. And they want the first 5 terms with the common difference being 7. Now this is our first term. Let me write first at the bottom here. Please excuse the handwriting, thank you. And what can we do to find our second term? Or since our common difference is 7, we are going to have to add 7 to 8 to find our second term. Now 8 plus 7 is what? 15, right? Good. So this is our second term. Next, we want to find our third term. What will we do? We will add 7 again to get our third term. Now when we add 7 to 15, we will get 22. Okay, so I wouldn't write third at the bottom there, but we can see that this is term number 3. Now remember, they want the first 5, so we keep going. We add our next 7 to the 22, and what will that give us? 29, correct. That's our fourth term. And lastly, we want our fifth term. We're going to add 7 once more to our 29. And what will we get? Correct, 36. Now these are the first 5 terms that we would get using our arithmetic progression rules, which was our first term being 8, and the common difference was 7. So now we have a sequence showing 8, 15, 22, 25, 29, and 36. Let's look at a second example. Good. Now this is a given sequence here. Now they gave us the sequence this time. The given sequence is 4, 6, 8, 10, and 12, etc. Right? So it goes on. It's infinite. They want us to find, or at least to show, what is the first term, and then we will show what is the sixth term. Now remember, the first term is usually the first number that they gave us in the sequence. And what will that be? 4, exactly. So that was simple, right? The first term in this sequence is 4. Now they want us to find what the sixth term is going to be. Now 4, 6, 8, 10, and 12, those are just 5 terms. So they want us to find the very next one, which is the sixth term. Now I will share with you how we are going to find that on my whiteboard. Good. So let's just write back the sequence here. 4, 6, 8, 10, and 12. These are the first 5 terms, and they want us to find the sixth one. Now, what do we need to do in order to find the sixth term? We have to look for the common difference, right? Meaning, how many numbers did we add or subtract to get to our next number? Now, these numbers are increasing, meaning they're going up. So obviously, we had to add. We're not subtracting in this case. We're adding. Now, to get from 4 to 6, we added how many numbers? Just 2, exactly. We're adding 2 in each case to get to our next term. 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 2 is 12. So to get our sixth term, we add 2 once more and we will get 14. So our sixth term is going to be 14. And that's how we find it. I will now hand you over to my next colleague who will show you some more examples to find our arithmetic progression answers. Thank you.
Great. So Miss had taken you through sequencing, specifically arithmetic progression with a common difference. Now I'd like to expose you to a worded problem, which reads, Mr. James decided to start saving money every month. The first month he saves 200. He plans to increase his savings by a fixed amount each month. By the 12th month, he is saving 750, right? So, one, it says to find a fixed amount or common difference by which he increases saving each month. And two, the total amount of money he saves in the 12th month. Can you see me? Can you guys see me?
Yes, miss.
All right. Just for a sec, please. All right, I'm sorry. So let's proceed by sharing my whiteboard. I had a formula at the back of me, so it's going to guide us through. However, we first need to find the common difference. Now, the first and last term was provided. So how would we find this common difference? We first can identify the given values for the formula. And I'll do so by working on a whiteboard. Okay, now we know the first term, A1, is 200. A12, which will be our last term, is 750. Now, what is D? We yet to know that. Now we will plug it in to our formula that Miss had mentioned earlier. And we would work or substitute, which is N being the number of term presented, which is A12, which was the last term, would be 750. A1, the first term, 200, plus 12 minus 1. And you put the D at the back. Now we can work the bracket first. And we group like terms. Now, there's a sign in front of 200, which is a positive. When it's taken over, it will become negative. Thus, we're subtracting from both sides. $200 from 750 would give us a difference of 550. So therefore, D would be 550 over 11. We now will divide 11 into 550 will give us a answer or quotient of 50. So we can safely say our difference is 50, which is our common difference. That's the A. The B part, we're now expected to find the total amount saved in the 12 months. So we're going to use our formula, Sn equal n divided by 2 or over 2, open bracket, A1 plus AN, close bracket or parenthesis, right? So let's identify our values. N, it's 12, A1 is 200, and A12, which is our last terms, is 750. Let's put it into our working and work. Sn will be S12 equal 12 divided by 2, open bracket, 200 plus 750 close bracket. Now let's simplify. And it's not correct if we do not put our dollar sign 0 cents. So the amount of money that he will save within 12 months will be $5,700.00. That has brought me to the end of this problem. Now I like to work example 4. Now it reads the arithmetic progression with negative common difference. The first term of an arithmetic progression, A equals 20, common difference, D equal -2. Find the sixth term. Now, our first term and common difference was given, right? So we have to work using an extended formula from the one that I just worked, which is Sn equal n over 2, open bracket, 2, 8, plus, open bracket, n minus 1, close bracket, d. Now I'm going to demonstrate that using the whiteboard.
Miss Renee, you're muted.
Are you hearing me?
Yes, Miss, go ahead.
All right. Sorry about that. Yes. Let me go again. We are working with the information given, which is we're going to identify our values given. We have A1, which is going to be 20, and the common difference. Was I muted all the time?
Just for this example, Miss.
All right. I was trying to explain that when the first term is given and the common difference is given, and they're asking us to find the sum, we're going to work with the example or the formula, sorry, Sn equal N2, open bracket 2a plus open bracket n minus 1, close bracket d. So we're identifying our values, which we identify a being 20 and the common difference being a negative 2. Now, the common difference, as Miss had mentioned earlier, can either be both positive or negative. So let's work at what we have. Yes, formula equals Sn. Now we're going to substitute the value into this formula that we have, which is S6 equals 2, 2, negative 2, because that is our common difference, right? And we will work 2 divided by 6 is 3, or half of 6. You can read it either way. Will give us 3. Or if you want to simplify it for the children, you can say how many times 2 can go into 6, which will result in 3. 224 minus 3, everything. Now, when we're multiplying, you're gonna have the negative, negative 10. So S6 equals 3. This is 3. Sorry, this is 40. 3 times, you wonder how I derive a 3. 3 times 30, which will give us S6. The sum of the sixth term will be 90. So that has brought me to the end of the fourth example. And now we will conclude our presentation. So, in conclusion, an arithmetical progression is a basic but significant idea in maths. It has to do with numbers that are ordered in a certain way or sequenced in a certain way, with each term changing by a set amount. Students who learn about arithmetic progressions may spot patterns, solve real life issues using sequences, become ready for more. I cannot see. Sorry, I have it on my thing. Yes, using sequence and become ready for more difficult math concept like algebra and series. And again, we want to stress on arithmetic progressions. It has a common difference, whereas geometric progressions will have it changing. So, any questions? We now open the floor to our Q&A time. But before we do, I would like to share my screen once more. So, ask a question, which is out of the two examples that I'm going to give, which one can we find a common difference and why? So I have example A being square 18, square 16, and square 32, and B being square 8, square 18, and square 32. One more. Square 8, square 16, and square 32. Now remember, we must have a common difference. So out of the two examples, or the three examples, which one will we have? Which one will derive with a common difference? Now, persons looking into this might say C, because we're multiplying by 2. However, when we square 16, we have a flush whole number, right? So that would not work. We have different common differences there or terms. Now, so the correct answer would be B. We have a standard or fixed common difference. Yeah. So thank you.